So this week, as I said before, we're going to be looking at triangles. So triangles are something you study a little bit more when you take geometry. If you're in Algebra 1B, you've probably started doing some geometry stuff for MCAS. And then if you're in geometry, you might have already done Pythagorean theorem earlier in the year. But that's the goal for this week. We're just going to look at Pythagorean theorem. So I'll go through the notes, kind of explain what the theorem is, do a couple examples, and then I'll flip through some of the MCAS questions and just kind of give you a couple hints on some of those. But basically, when you're using Pythagorean theorem, the goal is to figure out how long the sides of a triangle are. Okay? That's the goal. Pythagorean theorem will only work with certain kinds of triangles. So we're going to talk about what kind of triangle it works with. And this week, that's the only kind of triangle that you're going to have. Yeah. All right, so here is the Pythagorean theorem. Okay. A lot of times we use the letters A, B, and C. You don't have to use those three letters, but that's what people use quite a bit. And it's A squared plus B squared equals C squared. Important thing to understand, though, is what is the A, the B, and the C. So the A and the B are the two short sides of the triangle. Okay, those are called the legs, and C is the longest side, and that's the hypotenuse. Okay. So whether you call them A, B, and C, or X, Y, and Z, it doesn't matter. Okay. As long as you understand that if you take that and square it, take the length of that side and square it, it's equal to the length of that side squared. Okay. So that's Pythagorean theorem. So A and B are the legs, I just said that. Hypotenuse is always across from the 90. And does anybody know what symbol you have in that picture that tells you where the 90-degree angle is in that triangle? Anyone have an idea? Yeah?
The square in the bottom corner.
Yeah, this little yellow square right there. So when you draw a triangle and you put that little mark right there like that, that means that it's a 90-degree angle. And the hypotenuse is always the side that's across from that. So even if you draw your triangle a different way, the hypotenuse is always the one that's across from that 90. Okay? How you draw your triangle, that doesn't matter. Okay, you can have your triangle facing any way you want. Like I tend to draw it like that. Some people draw it the other way. That doesn't matter. All right, let's try an example. So the directions are missing. But usually when you have a triangle and it gives you two of the sides and it wants you to find the third one, the directions will say solve. Let's see if we can solve that one. And the first thing we want to do is just label anything that doesn't have a label. Okay, so I see that the top side is labeled C, so that's good. What letter could I use for the bottom side?
A.
Yeah, I could use A or B, doesn't matter, as long as it's not C. A, so if I use A for the bottom, then what's the 18 going to be?
B.
That's going to be B. Yep. So now we're going to fill in that for A, and fill in that for B, and C we don't know, so we're just going to leave it as C. Okay, and the formula we're going to fill those three things into is right there. A squared plus B squared equals C squared. Okay, so let's write that down. Okay, I'll put some calculators out because a lot of times when you do square numbers, they can get kind of big, so it's easier if we have a calculator. So for A, we're going to plug in 80, and we square it. For B, we're going to plug in 18. We don't have to worry about writing the label. I don't usually do it as I go through the problem. I'll write the label on the end. Okay, when I get my final answer, just put a label of kilometers on it, because that's the unit that they used. So now let's bring up our calculator and and do that. All right, so on this calculator, it's going to be the same pretty much as the ones I let you guys use. You just type in the number, hit the exponent for squaring. You could also use the caret key, that's the little up arrow, and put in a 2 to square it. But there is a button for squaring on the calculator. It's just a little faster. Okay, so we get 6,400 plus, and then 18 squared. That's a little harder without a calculator, so we're going to use that to figure it out. 324. Okay, and what do I get if I add 6,400 and 324?
6,724.
Yep, 6,724. Now that's not C. 6,724 is C to the second power. What we want is that. Okay, so I've got to get rid of this exponent of 2. Now if it was times 2, I would do divide by 2 on both sides, but it's not a times 2, it's a raised to the second. How do we get rid of raising to the second power? Anybody know what the opposite of that is? Yep. No, not dividing. If it was C times 2, then we would divide. But this is C raised to the 2. Yeah, we have to take the square root. So take the square root of what's on the left, and take the square root of what's on the right. When you square a square root, they cancel each other out. Right? It's kind of like if I said add 5 to a number and then minus 5. Well, it cancels out. Minus 5 plus 5. Same thing here. Square, square root, cancels out. And now, usually we don't get nice answers. We might, we'll see what happens. But that's why we'll use the calculator. Okay, on the calculator, at least on mine, you have to press second, and then you can press the squared button, and it'll do the one that's above it, which is square root. So 6,724. All right, we do get a nice answer. Okay, so 82. And that needs a label, because all the numbers originally had labels. So that should be 82, what should I, yeah, kilometers. Yep. So that's an example of using the Pythagorean theorem to find the longest side when you know the 2 shorter sides. If I would have found this number and it came out smaller than either one of those, then something's definitely wrong. Okay. C should always be the biggest side. Okay. So let's look at this one. So this time it's a little bit different because they are giving you the longest side, and they're having you find one of the shorter sides. So let's put our letters. The side that's 75 inches, what could I use for a label? Yeah? Yep. So we definitely want to use A. And then the side that's 85 inches, we're going to use C. Okay, so take our formula. That's the formula that you're going to be using pretty much every problem. And you're going to fill in everything you know. So we know A. But this time we don't know B. So we're just going to leave it. And C is 85. Okay, another thing that will not come up in these kinds of problems are negative numbers, because we're talking about the length of something. And when you're dealing with length, length can't be a negative number. It can be a decimal, but it won't be negative. All right, so let's do 75 squared. Let's do 85 squared at the same time. All right, so we got both of those. Just put those up there. Okay, so 75 squared, 5625 plus b squared equals 85 squared is 7225. Okay, now what's a little different about this one is the variable is not by itself. We've got something here that we don't want next to b squared. Okay, how would I move the 5625 to the other side? know how we would move that over? Yeah? Yep, perfect. We're going to subtract it. So when you subtract it from that side, 5625 minus 5625, you're left with 0. So that's gone. And now, all we have on the left side is b squared equals. And on the right side, well, we're going to take that in. 7225 minus 5625. So that gives us 1600. Now we're at the same step we were in the last problem. I want b, so I'm just going to put that over here. I don't want b squared. How do I get rid of that exponent of 2?
Square root.
Yep, take the square root of both sides. Squaring and square rooting, they cancel each other out. So now we have b, and that was 1600. You just can't see it anymore because I drew it. Okay. And the square root of 1600, it's like doing the square root of 16 but putting a 0. So it's going to be a 4 with a 0. And was there a label? Yeah, I should put inches on that. So 40 inches. Any question on that? All right, so both of these problems, they gave you a diagram to start out with. In a word problem, you don't have a diagram. So that would be my suggestion. The first thing you want to do with a word problem is make a diagram. You draw a triangle. All right, so it says a squirrel lives in a nest that's 12 meters high in a tree. To reach an acorn that is 5 meters from the base of the tree, how far will the squirrel have to glide? All right, so let's see if we can draw a diagram and then see if a triangle kind of pops up somewhere. Okay, if you don't get a triangle in your diagram, you probably didn't draw something right. Okay, so we got a tree. That's important. So, a wonderful tree. To reach an acorn that is 5 meters from the base of the tree. So here's the base of the tree. So the acorn is over there. They're rolled 5 meters away. So the squirrel is, let's say the squirrel is up in the tree. Okay, the squirrel's over there. Acorn's over there, and what's going to happen is the squirrel is just going to glide down from the top of the tree straight down to the acorn. Just like that. We want to figure out how far the squirrel has to glide from the top of the tree down to the acorn. Okay. Well, we know how high up in the tree the squirrel is. How high up does it say the squirrel nest is?
12 meters.
12 meters. So if we draw a line straight to the ground, it's 12 meters from the top of the tree all the way down to the ground. So that's 12. And we know how far away the acorn is from the bottom of the tree. How far away does it say that the acorn rolled from the tree?
5 meters.
5 meters. So that's 5 meters from here to here. So there's our triangle right there. So that's the height of the squirrel nest, how far away the acorn rolled, and then how far the squirrel has to glide. So I can take that triangle, put it off to the side. And now I'm going to label everything that I had. I'm just not going to have the tree and all that stuff anymore, just the triangle. 12, 5, and that's my 90-degree angle right there. All right. So now we're going to find the length of the hypotenuse. All right. What could we use for a label for the 12? Would that be A, B, or C? Yeah?
A.
Yeah, it could be A or B. Just don't make it C. How about the 5? Would that be B or C?
B.
Yep, let's make that B. And that's side C. Okay, so now we're going to do a squared plus b squared equals c squared. A squared is 12. B squared is 5. All right, now let's do it out. 12 squared. What's 12 times 12? 144. And 5 times 5. 5 squared is 25. Good. If we add those two together, it's going to give us 169. And my last step to get rid of that exponent of 2 is to do what on both sides?
Square root.
Yep, I'm going to take the square root on both sides. Squaring and square rooting cancel. And that one does come out nice. Okay, 13 times 13 is 169. So that means the squirrel is going to glide 13 meters from the top of the tree, or wherever the nest is in the tree, down to the ground. Any question on that? All right, and the last one. It says Wyatt takes a rectangular piece of fabric. Okay, that's the first thing I would do. I would draw a rectangle. Okay, let's make a rectangle. And he makes a cut along the diagonal from one corner to the other. So I'm going to represent that cut as a dotted line. The cut he makes is 17 centimeters long. That's the cut from corner to corner. Let's label that as 17. And it says the width of the fabric is 15 centimeters. That's the width of the rectangular piece of fabric that I have. So that side is 15 centimeters. It says, what is the length of the piece of fabric? That's that from there to there. They want to know how long it is. So by cutting a diagonal, you've made a triangle. Your triangle is right there. And it doesn't matter whether you look at the top half or the bottom half, it's the same triangle. All right. So we know that the diagonal is 17 centimeters. We know the width of the fabric is 15, so that part is the height of my triangle. That's my 90-degree angle because that's the corner of the rectangle, right there. And they want to know what is the length of the fabric. Okay. What letter should I use to represent the length? Yep.
17 is C.
Okay, so the diagonal is going to be C. Okay, so that's C. How about the 15? That's going to be why? What should the 15 be labeled as?
A.
Yep, we can label that as A. And the only letter we haven't used is B. So I'm gonna save solving that one for you because I want to show you something else. Okay, but you just fill those in, and that's going to be like the second example we did, where you're solving for the length. I think that was example 2. Yep, it's going to be just like this one. All right, so I want to take a look at the activity. On yours, it doesn't look as squished. I think it's because I kept it in portrait and it's actually landscape, but that's okay. So when you do the activity, they're going to give you on the back a bunch of different distances to find. And it's all going to come down to basically using triangles in this picture. So like the first thing they ask you to find is the distance between the ticket office and the Ferris wheel. All right, well, let's see if we can find those two things. Here is the Ferris wheel. And the ticket office is, I know it's hard to see, but it's probably a little less squished on yours. That's the ticket office. So whatever two things they want you to find, I would mark those two things, okay, so you know what you're looking at. Okay, the next thing is, can you draw a triangle between those two? Okay, so now you need to try to figure out where the triangle is. And in this one, the triangle is right there. So now what you're doing is you're using this triangle and you're solving for the height of it. You already know two of the other sides, so you can use Pythagorean theorem to get the third side. All right. Now, once you find that side, that's going to enable you to work with more triangles in the picture. Because now, if you had a problem where, I don't know, you had to work with this triangle right here in a later question, now you could. Because you know from here to here, they labeled that one for you. You didn't have this one at the top originally, but now you do. Okay? So as you go through, you'll be able to find more sides and then find more of the triangles. If you have a question, let me know, because if you get this part wrong and then you use that to figure out something else later on, then that's going to be wrong too. So if you get stuck, it's probably better to just check in with me right away, because some of your answers are going to build on each other in this part. All right? Okay, so that's your that's the activity. And then there's one MCAS question I wanted to look at. I think questions 1, 3, and 4 on the MCAS, those are pretty straightforward. But question 2, there's a formula that you might not remember that you need. Okay. So question 2, they give you a circle. You might be thinking, well, what's a circle have to do with the triangle? Well, you draw a line right in the middle of the circle, and then they draw something like that. This is supposed to be a 90. This is an 8. And that side's a 6. And what they ask you to find in this picture is the circumference of the circle. So circumference is this. It's that distance all the way around the circle that I just traced. If you don't remember it, the formula for the circumference of the circle is pi times the diameter. That's the formula for circumference of the circle. Pi times diameter. But they didn't give you the diameter. Does anybody see how you could find the diameter? Using the 8 and the 6. Yeah?
You have to get angle C.
Yeah, you have to get side C. That's exactly it. You're going to use Pythagorean theorem on that triangle. Then it's going to tell you this. That's not the answer. That's just the diameter. Once you know that, you fill it in. Then you can find the circumference. So that's what we're looking at this week. Okay, so that's the Pythagorean theorem.